Hello. Today we're going to demonstrate how a Xilinx 60nm Kintex UltraScale Plus FPGA can meet the aggressive performance goals of today's programmable designs while still meeting demanding low power requirements. To begin with, the UltraScale Plus family utilizes the TSMC 60nm FinFET Plus process, allowing Xilinx devices to achieve considerable gains in performance while maintaining very controlled static leakage power. This allows us to design our UltraScale Plus devices to operate at two different voltage levels and allows customers to choose which option is best for them, even late in the design cycle. Here we're showing a table illustrating the performance and power improvements of the UltraScale Plus devices compared to our highly successful 28nm 7 series family. When operating at 0.85 volts, the Kintex UltraScale Plus device achieves an exceptional performance increase of 60% while still reducing power by 20%. This equates to a 2x performance per watt improvement. However, for those wishing to achieve even greater power savings, the same device can operate at a lower 0.72 volts. In this operation, power is cut in half while achieving a 20% performance improvement for an amazing 2.4x performance per watt improvement compared to our 7 series devices. In other words, the 0.85 volt option can be used for those demanding designs that need faster performance, and the 0.72 volt option can be used for significant power savings and enough performance for most other applications. And the best part is, you don't need to make that decision up front. These options can be used to accelerate the development. Early prototypes can be developed at the higher voltage, thus attaining faster time enclosure and earlier validation, and then later at production delivery, time enclosure can be achieved at the lower voltage for much lower power consumption. So now let's see the performance, power savings, and flexibility that having this dual operating voltage offers. I've created a demonstration design consisting of 100 64-bit wide by 2K deep memories running at 400 MHz. The design writes a random data pattern to the full depth of the RAM and then reads out the data and starts that cycle over. This represents considerable memory bandwidth at approximately 2.5 terabits per second continuous memory access. I'll first download our design to our 28nm Kintex 7 device, the XC7K325T, operating on our KC705 demo board. This design consumes approximately 90% of the RAM resources on the device. Using the Texas Instrument Fusion Digital Power Designer software, I'm able to monitor the power on the primary core rail and see that for this design, I'm consuming approximately 5.3 watts of power on the core rail. This is not bad for such a large memory bandwidth. However, let's see what the same design looks like at 60nm UltraScale Plus FPGA. Here's the Xilinx KCU114 board featuring the Kintex UltraScale Plus KU9P device in a -2LE speed grade, offering dual voltage operation. I'll download the same design used in the prior 7 series demonstration. I'll first run the device at the nominal 0.85 volts. Please note that this same design can run close to 625 MHz in this device at the voltage. However, I will keep it at 400 MHz in order to allow power to be directly compared to the 7 series device. Let me set this to operate at the same 400 MHz now. The GUI on the screen is displaying the power dissipated on the primary core rail as well as the DRAM rail. As you can see, we're dissipating about 3.7 watts, doing the exact same functions as before. This is about a 30% power savings compared to the prior measurements, even better than I previously stated. But now we have a much higher ceiling of performance to operate under. Now let's drop the voltage to the lower 0.72 volt operation. Note that the performance level at this is still more than 10% better than we were able to achieve before with the XC7K325 device. Only now we're operating at less than 3/4 of the voltage. We're now consuming 2.8 watts of power, doing the exact same operation at the exact same performance. This is nearly half the power seen before in the 7 series device, and this does not factor in any of the architectural improvements like VRAM Cascade, which can further improve power efficiency. I hope this demonstration has shared some insight about the performance, power, and flexibility offered by the dual operating voltage in Kintex UltraScale Plus devices. This is just one of the many improvements we've made in this device architecture in order to deliver unmatched performance per watt metrics. For information on UltraScale Plus FPGAs and power efficiencies, and to download a power estimator to estimate power consumption in your own design, visit xilinx.com/power. Thank you.